So 3 years ago, we discovered LaunchDarkly, which is feature flags as a service, and it completely revolutionized the way that we approach application development. But it hasn't been all roses and unicorns and flowers and butterflies, because feature flags introduce a certain kind of technical debt into an application. At first, they really help you roll out features safely, but if you don't remove feature flags after they have served their purpose, then they sit there in the code base rotting, creating this obfuscated control flow and misleading code and unclear control flow and expectation. So what I wanted to do was create a utility that would essentially allow me to look at all of my feature flags in LaunchDarkly and compare them directly to my local code base and give me a way to sort them so that I could find feature flags which were ripe for removal from the application. So essentially what this does is it goes to the LaunchDarkly API, then it scours my local code base and it looks to see which feature flags show up in which files. It's a very brute force, but it turns out to be a fairly nice approach. And you can see here I can sort by date, descending, right? So here's feature flags that were created today versus we can see feature flags created back in 2016, 3 years ago, 3.5 years ago, I guess almost 4 years ago at this point maybe. And then we can see for each one of them, not only the creation date here, but potentially a list of files within the application that reference that feature flag. And of course I'm obfuscating them here a little bit just because these are actual values that we use. So I can sort it based on date, but then I can also sort it based on references. So we can see which feature flags are actually mentioned in the most number of files. Of course, if we do it by ascending, we can see a whole bunch of feature flags that are old and aren't referenced at all in the ColdFusion code or the JavaScript code. Now technically in our context these might actually be owned by a different application. That was a mistake that I think we made in the way we're organizing our feature flags. But anyway, let's take a look at how this works under the hood, because it was actually kind of fun to write. Again, very brute force. So there's just two files. Essentially there's a search results page and a locator component. Now the search results, actually let me just scroll down here to the bottom, which essentially you can see here are sorting options, date ascending, references ascending, descending, and so on and so forth. And all we're doing here is looping over the sorted collection. Again, I'm obfuscating the key just because it's live data. And then we're outputting the creation date and the list of code references, right? And then we're getting the file path. So that's what we're seeing here, essentially. Now, the fun part of this is that this feature flag locator is actually doing the heavy lifting within this demo, which means that it's going to the LaunchDarkly API and then it's comparing those feature flags to the local file system. That's a lot of work. So to make this demo more consumable, what we're doing is we're wrapping this in an immediately invoked function expression, or IFI, and you can see that we're applying that cached within function memoization feature in Lucee so that we can refresh the page, right, to do these different sorting options without having to incur the cost of going back to LaunchDarkly and the local file system, right? So we're going to cache the results of this for an hour. So we get the results for an hour, and then we can sort them, and we're sorting those cache results at this point here just based on whether or not it's the creation date or the reference count. Now, this is relatively straightforward, so let's take a look at the feature flag locator. So the feature flag locator takes my LaunchDarkly credentials for the API token. I provisioned an API access token specifically for this, so it's a read-only token, which means that even if this token were compromised, nobody could really do anything with it. And then I'm calling this search for feature flags. I'm passing in the list of directories that I want to search for code files, and then the type of files that I want to examine: ColdFusion components, ColdFusion markup, and JavaScript. So let's take a look at this, because again, it's very brute force. So if we look at the search for feature flags, this reads very procedurally. First we go to LaunchDarkly to get the feature flags. Then we compile the flags down into a regular expression pattern. Then we go to the local file system to find all of the file paths in these directories that match these file extensions. And then essentially what we do is loop over all of the file paths, take that regular expression pattern, match it against the file path content, right? So we're reading in that physical file, that code file, performing the regular expression search on it, And then for each match within that file, we're grabbing the key, the feature flag key, and I can show this pattern in a minute and that'll become more clear. And then we're simply using that key to look at the results, and then we're adding the file path to the references, and then we're incrementing the code count. So this will say like, this feature flag was referenced 6 times, and it was in these 3 files, for example. And that's that method. So very procedural, getting the feature flags, compiling the pattern, locating the files, brute force iterating over the files, reading in the content of each file, checking the regular expression pattern against that file content, and then keeping track of those matches. Again, very brute force, but remember, because we're using this closure here, this CFML closure with the cache within, the first time we hit this page, it's actually pretty slow. It takes like 2 or 3 minutes on my computer, but then every time after that, for the span of an hour, it loads instantaneously because all of that brute force work is being cached. So let's take a quick look at this pattern, because feature flags, that's just an HTTP request. File path, that's just a directory list. Really, compiling the pattern is the interesting part of this entire demo. So if we jump down to this, what we can see is we take the feature flags array, and essentially what we're doing is we're plucking that key out of the feature flags, and then we're creating an OR regular expression pattern, which we're going to then group in this capturing group here. So essentially this is key A or B or C or D, and so on and so forth. And then for my particular application, I'm saying that this key reference has to exist inside of a quote, either a single quote or a double quote, and you can see that we're matching whatever the first group there is. And then we just compile that using Java's utility classes. So this actually generates a giant key, right? So our application currently has over 600 feature flags. So essentially this key list has 600 ORed items inside of it, which we then enforce within a quoted context, a quoted string. And that's what we're then, that's that pattern we're then using to match against the file content of each file. So again, incredibly brute force, right? When I first thought about doing this, I was like, oh, that's stupid. This will take forever. But then I remembered, wow, computers are actually super fast, and this is actually pretty reasonable once you start building it. And especially once you add in caching, then like it's a no-brainer, right? Again, we can come back here, and these are all just refreshing and using that cached data. So what I'm hoping now is that I can start to look at this, and I can look at creation dates, I can look at reference counts, and I can start to formulate a plan of which feature flags are able to be removed from the application, especially in terms of level of effort, right? Like if I look at, well, here's a feature flag that was created, again, 3.5 years ago, and it's only referenced in 2 places, well, that's probably pretty easy to remove. So I can go in and create a Jira ticket to remove that. And then some of these, you know, maybe I can just remove from LaunchDarkly entirely because they don't seem to be referenced in the code. And again, I can start to formulate this plan of how I can attack the code rot and the technical debt that is actually introduced by feature flags. Even though feature flags are amazing and revolutionary and I can't develop an application without them, doesn't mean that they won't incur cost over time, and I want to be able to pay down that debt in order to make the application more maintainable. So anyway, hopefully this was interesting. I love feature flags, but I also love getting rid of feature flags as soon as I can.